Determining the uncertainty in the results of arithmetic calculations. See here. Suppose the measurement given to us with error, that is length L equal to 16.2 plus or minus 0.1 centimeter. Now here the true value, that is 16.2 plus or minus error, that is 0.1. So when here some calculations are carried out, suppose here we calculate the relative or percentage error in the measurement of length. Then delta L by L into 100 equal to 0.1 upon 16.2 into 100. Then whatever is your answer, but see here the error appears, that is with one significant digit, and that is after decimal point. So here you have to represent the final result in error with only one significant digit after a decimal point. So you can rewrite this length as 16.2 plus or minus 0.6 percentage. Clear? Now breadth B, that is 10.1 plus or minus 0.1 centimeter. For that, if you calculate the relative error, then percentage error, then 0.1 upon 10.1 into 100, your answer come to 1%. So here in error only one significant digit is there. So in result you have to restrict this one only up to 1. So that is 1%. So you can write B, that is 10.1 plus or minus 1%. Clear to all of you? Now length into breadth. So length, that is 16.2 plus or minus 0.6 percentage into 10.1 plus or minus 1 percentage. So here in the product of two physical quantities, true value is multiplied with true value. So 16.2 multiplied with 10.1. So that is 163.62. And in multiplication or division, we discussed this thing. The relative error or percentage error in the final result will be sum up. So 0.6% and 1%, that is sum up here. So that is 1.6%. Clear? Now here suppose you write this one in terms of absolute error, then you can calculate this thing like this. Percentage, that is always per 100. So we can write per 100 the error, that is of 1.6. Therefore in 163.62, how much? So 163.62 into 1.6 by 100. So it will come to 2.6 centimeter square. Clear? Now we have to represent the final result with proper number of significant digits. So see, in the measurement of L and B, the true value, that is with 3 significant digits. So here the true value, this one 163.62 that you have to restrict up to 3 digits. So 1, 6 and up to this one. So finally when these insignificant digits are discarded, then it is greater than 5. So add 1 in the previous one. So your true value, that will be 164. Then see this absolute error, that is with one significant digit. This absolute error, that is with one significant digit. So here this absolute appear with two significant digit. Again you have to restrict it up to 1. So discard 6, which is greater than 1. Sorry, greater than 5. So add 1. So your final result, that is 164 plus or minus 3 centimeter square. Clear? Say, in reciprocal, the rule is slightly changed. Why and how? Let's discuss this thing. Suppose we have the figure 9.58. And if we take reciprocal of it, so that is 1 upon 9.58. So your result, that is 0.10438. Now 9.58, in that total 3 significant digits are there. 1, 2 and 3. So suppose we restrict this particular result up to 3 significant digits. Now here this discarded finally, that is less than 5. So the previous one, that is as it is. So your result, that will be 0.104. But suppose you take 1 upon 0.104, then your answer turns to 9.615, and then if you rounding of this one and give final result with 3 significant digits, you will get 9.62. Means using the rules of significant digits and rounding off, if you take reciprocal of 1.8, then whatever is the answer, and again now if you take the reciprocal of that answer, then you are not getting the original value. Clear the point? Now when using the rules of significant digits, when we take the reciprocal of reciprocal, then we are not getting the original value. So here what we have to do, when first we take the reciprocal of the given figure 1 upon 9.58, at that time whatever the result obtained, in that result we have to keep the total number of significant digits one more than in the original value. Now see, in this original value 9.58, total number of significant digits are 3. But now in this final result obtained by reciprocal of it, we have to keep one more significant digit. Means this final result that we have to represent with 4 significant digits. So 104 and then this 4th significant digit. So we have to discard only 8. Now 8 is greater than 5. So rules of rounding off will remain as it is. So here we have to add 1. So if you take the final result as 0.1044. Then after, if you take reciprocal of 0.1044, then you will get the same result, 9.58. So here when you take the reciprocal at that time, just the rule is changed like this. The final result that you have to represent with one more significant digit appearing in the given measured value. એના કરતા એક ડિજિટ આપણે વધારે અહીંયા બતાવવાનું. ક્લિયર?